Okay, let's solve some questions based on the concentrations of solutions. So this question is about the molarity. Okay, let's understand what is molarity, then we'll take this question. Molarity is represented by capital M. Okay, it is what? It is number of moles of solute upon volume of solution in liter. Just understand this. So volume of solution should be in liter, right? You can either convert it or ml to liter you can convert directly, or if you are writing that in ml over here, so you are multiplying 1000. So there will be some books which will be showing this way. There will be certain books which will be showing this way. So number of moles of solute upon volume of solution in ml. If it is in ml, so this is what you are multiplying 1000, right? Means this together, this quantity together, numerator it is 1000, means this represents that volume is in liter actually. So what I'll suggest is, you do this independent. Don't think of this 1000 much. Don't think of, you consider only this as a formula. This 1000 may at this level will confuse you. Whatever may be the units of the volume of the solution is given, I'll suggest that you directly first convert volume of solution, whatever is given, convert it to liter, right? So number of moles of solute. See, solution is made up of two components. Solution is made up of two components. One is solute and the other is solvent. Together it makes solution. So solute is a minor component, smaller one, and this is the major component, right? This is the major component. So this is what the thing. So what I'll do is I'll define this first. Number of moles of solute we'll find first, and then we'll convert a volume of solution, and then we'll substitute into a formula. That would be a more systematic way of doing this problem. Okay. So what is the number of moles of solute? Number of moles of solute. What is a solute over here? Solute is NaOH. Sodium hydroxide is a solute, right? In bracket, I will write a sodium hydroxide, NaOH, right? So it is equal to what? Number of moles of any quantity, any substance is given to be what? Given weight. How much is the given weight? 2.46. 2.46 divided by 40. 40 is the molar mass of the NaOH, right? Here molar mass is given. Sometimes they may not give you directly the molar mass. They will give you sodium, atomic mass of sodium is 23, hydrogen is 1, or an oxygen is 16. If this is given, then you have to find the molar mass of that sodium hydroxide. You add this value NaO and H. So together it will be 40. It would be given that way. So here directly given, so no problems. To 2.42 divided by 40. How much that comes to? Um, 2.46 divided by 40. That comes to 0.0615 moles, right? Now, what is the volume of solution in liter? Now, let's discuss volume of solution. Volume of solution in liter. So, what is given over here? 100 centimeter cube. A solution is made to 100 centimeter cube. Means after adding the solute to a solvent, final volume is 100 centimeter cube. Can I write this? 100 centimeter cube. So, what is this centimeter cube? Centimeter cube, 1 centimeter cube is equal to what? ml, 1 ml, right? Since 1 centimeter cube is equal to 1 ml. If there is a cube of this which is having length, breadth, and height 1 centimeter, 1 centimeter, and 1 centimeter, how much volume will be there in this? 1 ml. So this is equal to 1 ml. 1 ml means what? It is 100 ml. M is what? 10 raised to minus 3. M is 10 raised to minus 3. The prefix, a multiple of this is 10 raised to minus 3, and this is liter. So this is what? Zero, you can write this 100 into 10 raised to minus 3 directly in the formula, or you can just write it 0.1 liter. You can write it this way. So as of now, what I'll do is I will just put it 10 into 10 raised to minus 3. 100 into 10 raised to minus 3 into a formula. So therefore, molarity is what? 0 0.0, how much it was? 0.0615 divided by volume is how much I am getting. You can write 0.1 liter, or you can write this also, 100 into 10 raised to minus 3. So what is this? 0.0615 upon 100 into what? 10 raised to 3, no? When numerator to denominator, when you take it, it becomes 10 raised to 3. So what is this? 0.0615. This is 10 raised to 2, and this is 10 raised to 3. So here this will be 0.0615 into 10, like this, and will get cancelled, right? So it is answer is 0.615 molar. That is, units will be what? Capital M means it is moles per liter. Many times M means it is moles per liter. Other way this concept could be used in an exam is this way. Like this question asked over here is how many grams of Na2CO3 Na2CO3 should be dissolved in 100 centimeter cube of 0.15 molar Na2CO3? Means how many grams of, the question is, I'll make this statement again. How many grams of Na2 should be dissolved to make 100 centimeter cube of 0.15 molar Na2CO3, right? Here we'll write this Na. This should be given to you. This is 23 atomic mass of the. I'll just write the value, that is grams per mole. Sometime it will be given AMU. It is one and same, 23 only. Then a carbon is 12 grams per mole, and the oxygen, one oxygen is 16 grams per mole, right? How many grams of Na2CO3? So what we'll do is molarity is equal to what? Number of moles of solute upon volume of solution in liter. I am just changing this formula slightly, right? Uh, let's say, what is this molarity? Number of moles of solute. No, it is. I'll just write this. Number of moles of solute. So what is the thing? Number of moles of solute could be written as what? Weight of the solute upon molar mass. Capital M is for the molar. Okay, both the sides uh, it is yeah, both side it is this M and this M. Or I'll just write this molar mass of the solute. M solute. This is molarity. This is molar mass of the solute. Don't get confused between this M and this M. So this N I have splitted, divided by volume of solution. So this M I will write here. This M I will write over here. Since I will write how we are getting this, number of moles of solute is equal to weight of solute, that is weight supplied upon molar mass of solute, right? So this whole formula changes to what? This is in liter. Remember this. Solute upon molar mass of solute into, what is this? 1 by V of solution in liter, right? So what you are told to find, M, capital M is given. Which capital M? This M is given. How much is that? 0.15. Uh, weight of the solute, weight of the solute, that is what we need to find. Molar mass of the solute could be easily found out. Molar mass of the solute for Na2CO3 is what? 2 into 23 plus 12 plus 3 into 16 plus 3 into 16. So what is this? 46, 12, and 16 into 3 is 48. This is equal to 48 106. This comes to 106. So we have m of the solute to be 106. And then volume. What is the volume of the solution? It is 100 centimeter cube, 100 centimeter cube, which is equal to 0.1 liter. So we have all this value, we just need to substitute over here. Therefore, I write 0.15. Weight of the solute is what? Weight of the solute. That is what I need to find. Weight of the solute. I need to find this upon molar mass of the solute is what? 106. And volume of the solution in liter is how much? 0.1. So weight of the solute, weight of solute is equal to 0.15 into 106 and zero point 0.1. So it is 0.15 multiplied by 106 multiplied by zero point 0.1. So answer is 1.59 gram. This is what the answer for this. Okay. This question, next question is about the molality and the mole fraction. We'll solve this both the questions over here. Okay. 2.82 gram of glucose are dissolved in 30 gram of water, right? So this is what is molality? Molality is represented by small m. Understand this. It is again same number of, not same, slightly different number of moles of solute upon mass of solvent. Understand this. It is not a solution. Mass of solvent in kg. Right. This is what the molality is. L. It is molarity is different from the molality. So if you solve this independently, like over here, solution. Solution is what? It is solute plus solvent, right? So what is the solute over here? Solute is glucose, right? And what is the solvent? Solvent use is water, right? Understand this. So what is the number of moles of solute? Number of moles of solute is what? It is given weight 2.82 divided by how much? Molar mass of that is 180. So 2.82 divided by 180. 2.82 divided by 180. Answer comes to is equal to 0.01566. And what is the weight of the solvent? WEIGHT. Weight of the solvent is 30 gram. How to convert this to kilogram? See, it is very easy to convert kilogram to gram, right? It is very easy to convert kilogram to gram because kilo is 10 raised to 3. But how to convert gram to kilogram? See, it is very easy. Do this. 30, 30 is there. Just put kilogram. The story is not over here. You have added extra k over here, right? What does this mean? It is you are adding a 10 raised to plus 3, right? It is as good as you have multiplied 10 raised to 3 extra, which was not there over here. So to balance this out, you will multiply what? 10 raised to minus 3. So this term is balanced now. So it is as good as you have not done anything. 10 raised to minus 3 and this k is balance, right? So it is 30 into 10 raised to minus 3 kg, right? So this will be a simplest way to do that. And what will be a molality now? Molality will be 0.01566 divided by 30 into 10 raised to minus 3. 0.01566 upon 30 into 10 raised to 3. So 10 raised to 3 means what? 1, 2, 3 means 15.66 divided by 30. Approximately answer will come to 0.5, like 0.522. 0.522 moles per kg is the unit, right? This is the molality. Now, mole fraction of the glucose. I'll take this to a next page. Mole fraction of the glucose. Now, what is the mole fraction? 1 minute. Encodo in between disappeared. Encodo is the whiteboard software which I'm using over here. Uh, yes. Hope this is fine. Mole fraction of the water. Mole fraction of the water and the glucose and water. That is what we need to find. First, let's understand. If there are three component or a two component, let's say there is a solution, there is a solution. I'll take a three component system. You can take two, four, any component. Let's say there are components A, B, and C. How you will write the mole fraction of the A? It is a mole fraction means what? Number of moles of A upon total number of moles of all the component. This is mole fraction of A. This is a symbol which is a chi symbol. This is mole fraction of B will be what? Number of moles of B upon total number of moles of all the component Na, Nb, and Nc. What is the mole fraction of the C? It is number of moles of C upon total number of moles of all the components. Remember, whatever may be the number of moles, 1, 2, 3, sum of mole fraction of all the components, sum of mole fraction of all the components is always equal to how much? Equal to dash. Can you guess what should be the answer? Answer is 1. Means if you add this mole fraction of A, mole fraction of B, and mole fraction of C, then it should be is equal to 1. How? If we take LHS, LHS is equal to RHS, no? LHS I am taking. What is the number of moles of A could be written? Number of moles of A is written this way, no? Na plus Nb plus Nc. Mole fraction of B, number of moles of B upon Nc is what? So if you see the denominator is same. So this is Na plus Nb and Nc, just using mathematical rules. So this and this will get cancelled, which is equal to 1, which is equal to RHS, right? So sum of mole fraction of all the components is always is equal to 1. So now the question is we need to find the mole fraction of the glucose. For that, we need to know what is the number of moles of glucose. So number of moles of glucose is equal to what? Given weight is how much of the glucose? 2.82 divided by 180. How much that was coming? 2.82 divided by 180. It was coming to equal to 0.01566. This was the thing. Number of moles of water, how much it was? It is 30 gram. 30 divided by 18. So 30 divided by 18. That comes to 1.66, right? So what would be a mole fraction of glucose? It is number of moles of glucose upon total number of moles of all the components. Here it is just two components, glucose and water. So it is glucose plus water. So what is this? uh, 0.1 0.0155 156 0.1566 divided by 0.01566 plus 1.66, right? So plus this will be 0.01566 divided by 0.015, this? So answer is here. So answer is 1.67. This is a mole fraction of the glucose. Sorry, not a mole fraction. Mole fraction cannot be is equal to 1. So this will be a mole fraction. That is 0.01566 divided by 1.67. So mole fraction will be 0.0093 of the water. So you can directly use a formula, to find a mole fraction. Okay, I'll do this in this way. Mole fraction of the water will find. So I'll do this here only. Mole fraction of the glucose is done. So here only I'll write mole fraction of the water. You can use this formula directly, or you can do 1 minus glucose, mole fraction of the glucose. So water is what? 1.66. This is the number of moles, and down it is what? 0.01566 plus 1.66. So this is 1 by 66 divided by 1.67. So this mole fraction is 1.666 divided by 1.67. So answer is 0.9976. Right? This is what the answer. You add this value. If you add these values, the answer will be approximately or very close to 1 if you add these two values which I have circled over here. Now, once you find one of the number of once you find the mole fraction of one component without, if you don't want to use this formula, then you can do this way. That mole fraction of the glucose, see, not number of moles, it is mole fraction of the glucose plus mole fraction of the water is equal to 1. We have found out this value to be 0.0093 plus mole fraction of the water, which is equal to 1. So mole fraction of the water is just 1 minus 0.0093. So 1 minus 0.0093. Answer comes to the same way, 0.99 and zero 0.7. These answers are very close. It's that. So if 11 gram of oxalic acid, this question is based on a mass percentage. 11 gram of oxalic acid are dissolved in 500 ml of the solution. Density is given 1.1 gram of the solution. What is the mass percent of the oxalic acid? So what is the mass percentage? Mass percentage. It is just a percentage, remember. Like mass percentage is mass of solute. I'll write mass of solute upon total mass. What should be that? Is it a mass of solute or mass of solvent or mass of solution? Total mass means total mass, that is solute plus solvent, that is mass of solution. Mass of solution is total mass, right? Into 100. So what is the mass of solute? Mass of solute given to be is equal to 11 gram, right? Mass of solution is not given, right? Mass of solution is not given. It is what? A density is given in volume. So since to find mass of solution, we'll use this formula. What is that formula? Density is equal to mass upon volume. Therefore, mass will be is equal to what? Mass will be is equal to density into volume. What is density given? Density given over here is 1.1 grams per ml. I'll just write the unit also, and this is 500 ml. So this per ml and ml will get cancelled. So what remains is just 500. So 500 into 1.1 is 50. 500 into 1.1 is 550, right? So 550 gram. So we'll substitute that 11 by Okay, what is this happening? So mass percentage, therefore, mass percentage of what it is a solute, no? Mass percentage of solute is 11 divided by 11 divided by 550 because 11 gram was the oxalic acid. Remember this. So 11 by into 100. In this 100 is there. Don't forget this 100. So 11 divided by 550. 0.02. 0.02 into 100, which is equal to 2%. Okay, this was the numerical part which could be asked for your first mid test, possible mid test. This is the first 1 minute now. Yeah, numerical part which could be asked for the mid test, and the theoretical part, like you should by heart the laws, by heart all the laws, understand them, and some definitions of the like limiting reagent. This is also important. Then you can study definitions of molarity, molality, mass percentage, volume percentage. Then you can also study like new significant figures. I haven't done any of the questions regarding of significant figures because that is a common concept between a physics and chemistry. Many of the students know that. So I have just taken the questions which are there, possible questions which could be asked for a chemistry exam. Okay, that's it.